Hello everyone, I'm Siddhartha and the team from Hyderabad Institute of Technology and Management. I will be presenting my simulation for Simulink Project Challenge 2022 on single stage onboard charger for electrical vehicles. Before stepping into the topic, let's have some background on charging methods. To charge EV there are three levels. Level 1 is onboard charger, level 2 is wall mounted charger, level 3 is DC charging station. My topic is about level 1, that is onboard charger. It is a slow charging used in remote areas or in emergency conditions. Coming to the block diagram, input grid voltage supply is given to the rectifier which converts into DC and full bridge inverter to invert DC into AC up to 500 volts AC. After a high frequency transformer is used for changing the frequency and it rectified into DC approximately 400 volts to charge the battery. A control system is used for controlling the switching pulses of the switches to get the approximate output. Here is the circuit diagram. As we can see the inductor, it reduces the unwanted voltage supplies and at the end, capacitor is used to reduce the voltage fluctuations. And in inverter, we use two more extra switches for sharing of voltage stresses on the transformer so that we can reduce the temperature of the transformer and no snubber circuit is required. Here is the simulation circuit of single phase onboard charger. We give 200 to 230 volts of AC grid voltage to the converter which is further rectified into DC. Coming to the switches, we use 10 transistors as inverter and converter circuit. The switches are controlled by a control system. In this control system, we use second order integral controller to avoid the voltage spikes. We convert phase voltage into sequence voltage for steady state operation. A mode selector is used for the constant DC output by using a THD. The product of the input voltage of estimated output will be added to the input current and given to the selector line. And the product of the set value of current and reference current will be divided with the estimate output voltage which is further connected to the selector line. By using a saturation input, current is used the selector line. According to the duty cycle, PMW generate the pulses and respective switches will be turned on. As we can see, 200 volts AC supply is given as input to the circuit. After the diode rectifier, the DC 200 volts is given to the inverter. In the inverter circuit, the DC is inverted into AC up to 500 volts. Through a high frequency transformer, the battery and the grid voltage is isolated. Later it is again converted into DC approximately 470 voltages. We can see some distortions in the output due to presence of THD up to 3 to 4 percentages. Here we can see the total harmonic distortions in the circuit which is up to 3.03 percentage. And coming to the state of discharge, we can see the discharge of battery and the current and the voltage waveforms with some distortions in it which can be neglected.